The degree of this polynomial is 3, and that's because when this polynomial is in standard form, which it is right now, 3 is the highest exponent. That means it has 3 total roots. These roots can be real or imaginary. The possible real roots are always factors of the constant term because they have to multiply together to make -5 at the end. Those numbers would be plus or minus 1 and plus or minus 5 because 1 and 5 are the factors of 5. To test to know which one actually is a factor, you could actually plug in f of 1 and see if that equals 0. You could do this for each of the roots, or the possible roots, to see which one equals 0. As you can see, that's a lot of work, so we're just going to graph it, and then we can see which one's a real root. Also, the end behavior, this has positive end behavior because the leading coefficient is positive. So let's look at the graph. Here's the graph of this polynomial. Notice that it only crosses one time. That means a root is x equals 1. That is a real root. And obviously, since you only see it cross the x-axis one time, it only has one real root. You can tell by looking at this is not a linear equation. When you see a squiggle or a bump in the graph, you know something's going on, and that something is imaginary roots. So now we need to find what those imaginary roots are. To find the imaginary roots, we take the actual real root, which is x equals 1, and we factor it out of the big polynomial to reduce it to a smaller polynomial that we know how to solve. So, in order to factor out the root x equals 1, you're going to subtract 1 from both sides here, and x minus 1 is a factor. Now, we're going to divide x minus 1 out of this polynomial. You can use the box, or you can use long division. Since x minus 1 is a factor of this polynomial, when I do this long division, I should not get a remainder, or I've done something wrong. So to start the box, you always put the first term in the first box. So we're going to put x cubed here, and then we're going to divide this out. X squared times x makes x cubed. That's how we get this first number. Remember, we're multiplying. And so we have negative x squared. We have negative x squared, but we need 3x squared. That means this box has to be a 4x squared because 4x squared and negative x squared give you 3x squared. That means this box has to be 4x, and 4x times negative 1 is negative 4x, but we need positive x, so that means in this box we have to put positive 5x, and that'll give us that, and this means x times 5 is 5x. 5 times negative 1 is negative 5. Since we got negative 5 here, which is what is here, we are finished, and that means we did it correctly because x minus 1 is a factor, so we should not have a remainder. And that means this polynomial equals, as we saw in our box, x minus 1 times x squared plus 4x plus 5. This quadratic does not factor. And we know it does not factor because if it factored, we would have had real roots. We're going to have something imaginary going on. So right now, you can either solve this one of two ways. You can use the quadratic formula, or you can complete the square. Quadratic formula is big and messy and yucky. Yes, it's a great fallback if you don't remember how to complete the square, but you're much wiser to complete the square because it's much easier. So to complete the square, x squared plus 4x plus 5 equals 0. We are going to subtract 5 from both sides to get it out of the way. And then we're going to complete the square. Remember, you have the 4 x's, and you're breaking those 4 x's in half. So you have 2, but then you're squaring it to complete the square. So you just added 2 squared to this side, so you have to add 2 squared to the other side as well. And now you can write this as a perfect square. X plus 2, quantity squared, equals -1. and then you take the square root of both sides. Please don't forget plus or minus. You have two solutions. So x plus 2 equals plus or minus the square root of -1, which we know is I. And then we're going to subtract 2 from both sides, which gives x equals -2 plus or minus I. And these are your two additional roots. So now we have 3 total real roots. We have x equals -2 plus or minus I, and x equals 1. And now we have our 3 roots. And don't forget, imaginary roots always come in pairs because of the plus or minus, which happens when you complete the square and also when you use the quadratic formula. Plus or minus the square root. All right, have a great day.